Okay, so on this lesson, we're going to be solving absolute value inequalities. So the last lesson we looked at, we were solving equations. The difference, we don't have an equal sign. We have a less than, a greater than, less than or equal, greater than or equal. So these are a little different than just a normal inequality. So we're going to have, anytime we have absolute value inequalities, if it's, after you isolate, if it's a greater than, you're going to be setting up an OR statement, and we'll look at that in just a second. If it is a less than absolute value, you're going to be setting up an AND statement, and that's what this is. And so your OR statement is two separate. So depending on, after you isolate your absolute value bars, depending on that sign, that will determine how you need to set up your two different answers or your two different inequalities like we did on equations. Okay, so first up, or for number one, we're solving the inequality. We're graphing the solution set on the number line if possible. So again, same thing as the equation. I want you to circle the absolute value bars. So that way you know you need to isolate it, which means I need to move the -8. And then I have absolute value of 7 minus x is greater than or equal to 18. Now, once the absolute value bars are isolated, you get it by itself, then you're going to set up your two inequalities based on your sign. If it's greater, that's the way that you can remember it. Greater is an OR statement. So I'm going to set up, without the bars, 7 minus x is greater than or equal to 18. Or 7 minus x. Now, if I change this to a -18, I have to flip this sign over here. That's a common mistake, forgetting to flip it, so make sure you flip it. So we're going to solve them separately. So we're going to subtract 7. We get -x is greater than or equal to -11. And then I have to divide by -1. So anytime we're dealing with inequalities, if you remember from Algebra 1, when you divide by a negative or multiply by a negative on both sides, you have to flip that sign. So that's x is less than or equal, and that becomes +11. Looking at the next one separately, we're going to subtract 7. And then divide by -1, which means we'll have to flip that. So that's going to be x is greater than or equal to +25. Okay, so there's my solution here. So x is going to be less than or equal. That should be actually a positive. So that should be a negative. My bad. So right here, what it was a +11, and then I divided it by -1. So -11 there. Okay, so there's my solution set there. So we're going to graph it on a number line. So kind of ran out of room here. So I want you to plot your 0 in the middle, and then I want you to do your -11 on the left of that, +25 on the right. So anytime we're dealing with inequalities, make sure you include or look at your equation or your inequality. If it's equal to, it's a closed point. So it's less than or equal to -11. So put a closed dot on -11. Everything less than is to the left. 25, it's closed, everything to the right because it's greater. So anytime you have an absolute value greater, you're going to set up an OR statement, greater or. Set up an OR statement, and then on your graph, you're going to have it going opposite directions. Okay, so let's take a look at number 2. So number 2, we have to isolate our absolute value. So I'm going to add 2. And that gives me 1/2 x plus 2 is greater than, that would be 11. So once we've isolated it, check your sign. It's greater, so that means greater. We're going to set up an OR statement. So I'm going to have the 1/2 x plus 2 is greater than 11. So whatever you have without the bars, or 1/2 x plus 2 is less than, don't forget to change it, negative 11. We have to flip that sign when we make that a negative 11. So solve them separately. Subtract 2. And then to get rid of a fraction, we've already talked about this, we flip it and multiply, so we'd be multiplying both sides by 2. So that's x is greater than 18. We don't need to flip it because we're multiplying by a positive. So then the other one, subtract 2, we get 1/2 x is less than negative 13. And then we'll have to flip it and multiply. So I'm multiplying both sides by positive 2, so I don't flip it. X is less than negative 26. Okay, so there's my solution. And then when we're graphing it, we have 0, I have a negative 26, and I have a positive 18. Notice it doesn't include either of them. So on this one, it says x is greater than 18, so it should be an open point when it doesn't include it. Greater's to the right, and then less than or equal to negative 26. So open and to the left. All right, let's take a look at 3. Now, if you wanted to check these, you would plug in points that are less than negative 26 and greater than 18. You can plug in test points and make sure that it's true. All right, number 3. So I'm going to isolate my absolute value. So I'm going to subtract 7. That's negative absolute value of x is less than, that's 7. And then we need to divide by negative 1. So we have absolute value of, notice that we divided by a negative on both sides, so we would flip that to a greater than, and then that's negative 7. Okay, so up here at the top it said make sure that we're paying close attention when we have a negative value or a 0, and make sure that it's possible. So notice here it says absolute value of x is going to be greater than negative 7. So we're trying to figure out what x values will be greater than negative 7 when we take the absolute value. That would be all real numbers, because anytime we take the absolute value of just x, we're always going to be getting a positive value. That will always be greater than negative 7. No matter what we plug in for x, it's going to be greater than negative 7. So our solution here would be all real numbers. You can also use the symbol. All right, let me do some erasing here. Okay, let's take a look at the next one. So circle your absolute value because you want to isolate it. Notice the negative 3 is not circled. We need to get rid of it by dividing it. Remember, when you divide by a negative, you have to flip that sign. So I have absolute value of x minus 1 is now greater than or equal. 12 divided by negative 3 is a negative 4. So again, pay attention when this side over here, after you've isolated your absolute value, is negative or a 0. So notice it says, what can I plug in here? Take the absolute value and it be greater than or equal to negative 4. Everything we plug in, we're going to be getting a positive number when we take the absolute value. So this is also all real numbers, so pay attention to that. Okay, let's take a look at the next one. So notice circle your absolute value. There's not anything that's not circled. It's already isolated. So I go straight into checking my inequality. It's greater. I set up an OR. So x over 5 plus 12 is greater than 6, or x over 5 plus 12 is less than negative 6. So I'm going to solve them separately. So subtract 12. That's negative 6. Notice here we're dividing by 5, so the opposite would be to multiply by 5 on both sides. Since we're multiplying by a positive 5 on both sides, we don't need to flip that. That's negative 30. Solving the next one, subtract 12. We get x over 5 is less than negative 18. Opposite of dividing is multiplying, so I'm multiplying by 5. And I get x is less than, I don't need to switch it because I'm not multiplying by negative on both sides. Negative 18 times 5 is a negative 90. Okay, so when we're graphing it on the number line, we have a 0 in the middle. Notice both of these are negative, which is fine. We need to put negative 90 over here, negative 30 here. Notice that it's not equal to on either of them. So it's open point on negative 90. It's everything less than, so go to the left. And then open, go to the right. Now I'll show you a little trick. If your variable's on the left side, your inequality, it'll be going that direction for your arrow, going to the right. This one going to the left. So there's a little trick that you can use if your variable's on that left side. All right, so I want you to pause the video, work on number 6, and then press play when you're done. So this one, we're isolating our absolute value, so I'm subtracting 6 first. And that's 5, divide by 5. And then it's greater, so I'm setting up an OR, so x plus 4 is greater than or equal to 1. Make sure if it's equal to on your original, it should be equal to on your solution. Or x plus 4 is less than or equal to negative 1. So you should get x is greater than negative 3. Or x is less than or equal to negative 5. So negative 3 comes first, then negative 5. It's equal this time, and less than, equal, negative 3, greater. So there's your solution on the number line. All right, let's take a look back. Okay, so notice this one says we're still doing compound inequalities. This says and. So we'll talk about what that is in just a second. So we're solving the inequality, we're graphing the solution. So isolate. So when we circle our absolute value of x, we're going to add 7 first. So we get 2/3 absolute value of x is less than 18. To get rid of that fraction, we're going to flip it and multiply. So I'm multiplying both sides by 3/2. So that 2 I can reduce, that'll be a 9. So 9 times 3 is 27. Okay, so we're going to set up, this one is, notice after we isolate, is less than. When you have a less than, you're going to be setting up an and statement, which looks like this. So set up an and statement with negative c and then c on the other side. So I'm going to set that up. So I'm going to put negative 27 and then use the less than symbol. I'm putting x, absolute value of x, and then less than positive 27. So notice this one we didn't have to do anything because the only thing that was inside your bars were just that x. So this is called an and statement. It's all together. Or statement, we had 2 separate pieces separated by an or. So I'm going to graph it. So I have 0, negative 27, 27. Notice it doesn't equal it. So it's open points. And it says x is less than 27, so to the left, but greater than, because you have to read the variable first, greater than negative 27. So it should be connecting. So if you notice on the front, all of them were not connecting because those were or statements. On the back, these are and statements, so they should be connecting. Okay, so let's take a look at number 2. So we want to isolate, so subtract 10. we get negative absolute value of x plus 2 is greater than or equal to negative 3. But we have to divide by negative 1, which means we need to flip that sign. I like to circle it so I remember to flip it. So I have absolute value of x plus 2 is now less than or equal to 3. Okay, so now once we have isolated the absolute value, we're looking at the sign. This is a less than, you set up an and statement. So I bring down without the bars that, but then I put the negative 3 on the other side. This is called an and statement. It's all together. We're solving it separately. So look on the inside, we need x by itself, which means we need to subtract 2. Now, this is an and statement, so we have to subtract 2 on all sides. That's a common mistake. Make sure you're doing it to all sides. That's negative 5 is less than or equal to x is less than or equal to 1. So when we're graphing it, we have 0, negative 5, and 1. It's less than or equal to 1, so equal to, close point to the left, and greater than or equal to negative 5. So close point everything to the right. So make sure if it's equal to on the original, make sure it should be equal to whenever you're setting up your and statement. All right, next one, isolate your absolute value. So we need to divide by negative 5, which will flip that. So that'll be the absolute value of x is less than negative 2. So remember, pay attention here. We ended up getting a negative. So it says the absolute value of x, we want to figure out what we can plug in here for it to be less than negative 2. It's never going to be less than negative 2. So this would be a no solution. Because anytime we take the absolute value of x, we're going to get a positive number. You can use the symbol. So pay attention once you've isolated the absolute value, if it's negative over there, make sure you're checking to see if that's possible. Okay, so looking at this next one, we're going to not have to isolate because it's all by itself. So it's a less than, so set up an and, so bring everything down without the bars. And then over on the far left, I need to put that negative 5 and just rewrite that symbol the same as it already is. So I need to get x by itself in the middle, so I first have to subtract 4. Remember, you have to subtract 4 on all sides. So that's negative 9 is less than negative 3/4 x is less than 1. And then to get rid of that fraction, I need to flip it and multiply. You need to also multiply with that negative so it becomes a positive. So make sure you're multiplying all sides by negative 4/3. So that's going to be 12 is less than x. My bad. Go back. So when we multiply by a negative on all sides, remember we have to flip those signs. So it should be 12 is greater than x is greater than, you have to flip both of them, negative 4/3. So graphing it, we have a 0, we have negative 4/3, and we have positive 12. Notice it doesn't include them. It says x is greater than negative 4/3, so it should be to the right, and less than 12 to the left. So they should be connecting with 2 open points because it doesn't include it. All right, so next one, isolate, so subtract 1. We have absolute value of 7 minus x is less than 0. Okay, so the front, remember we said always look when you isolate, see if it's negative. Also pay attention when it's 0. This is saying what can I plug in for x? Take the absolute value of it and it be less than 0. When you take the absolute value of any number, it's never going to be less than 0. So this is a no solution again. So pay attention after you've isolated and see if that number is 0 or negative, because you have to see if it works or not. Okay, pause, do number 6 on your own, and then replay it, and then you can check it. So no isolation here because it's already by itself. It's a less than, so we set up an and statement. So -9 on the other side. We want to isolate x, so subtract 21. So that's -30 is less than or equal to -3x is less than or equal. That would be -12. Okay, so now we notice we have a -3 in the middle, so we need to divide everything by -3. So if we divide all sides by negative or multiply all sides by negative, when we're dealing with inequalities, we have to flip the sign. That becomes +10 is greater than or equal to x is greater than or equal to 4. Okay, so drawing your graph, we have 0, we have 4, and we have 10. So it includes 4 and everything greater. So to the right, it includes 10, everything less than, so to the left. So you're always reading your variable first, so it's x is less than or equal to 10. So it should be connecting. So remember, anytime you're solving an absolute value inequality, if it's less than, you're going to set up an and statement, and it should connect on your graph. If it's a greater, you're going to set up an or statement, and it should be separate on your graph. If you have any questions, please let me know.